Hello YouTube. Today I am bringing you the first of many LeetCode videos where I'm going to be going over popular LeetCode problems, different algorithms, solutions in C++ and Python. So here we go. Let's kick it off with TwoSum. So I'm going to read the description, go into the theoretical, how we're going to approach the problem and the different algorithms we could use, and then I'm going to show you the implementations, like I said, in C++ and Python. So here we go. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So essentially what this question is asking is what two numbers of an array nums will add up to target. So we need to pick two of these numbers, add them up, and they need to equal to target. So what they would be looking for in this example is 2 and 7, or rather the indices of 2 and 7, which would be 0 and 1, because 7 plus 2 gives us 9. So there are a few different ways that we can approach this problem. The first is something that is very popular in LeetCode problems, and that is called the brute force method. So let me just give an example array. So let's say we have 2, 11, 7, and 15 as our nums array, and our target is going to be 9. So the brute force approach, what that involves, and if we use this in other problems, it's going to follow a similar theme. But for this particular one, we're going to be generating all possible pairs of numbers from nums. Because think about it, all we need are two numbers, and we know that we're going to get it from this array. So what we're going to do is we're going to generate and check. Yeah, I'm sorry for that too. 2 and 11, if we add them up, does it give us 9? 2 and 7, if we add it up, does it give us 9? 2 and 15, and if none of those give us what we want, we keep going. 11 and 7, 11 and 15, so on and so forth, and we generate all these pairs, and eventually, hopefully, we will come up with 9. This is a valid solution, but the problem is it's too slow. So it's going to be the runtime. The big O runtime is going to be n squared, and that's simply too slow. And it's O of n squared because for each indice, for each element, we have to iterate through the array again to generate all the pairs. So that's not going to be good. So we need to find a faster way. There needs to be a better solution. So let's do the same thing again. We have 2, 11, 15, and 7, and our target is going to be 9. If there was a way to just so that other example, we had to do it n squared times. We had to loop through the array tons of different times to get tons of different pairs. If only there was a way that we can just do a simple one pass solution, go through and be done with it. That would be amazing. So a data structure also commonly used in data structure and algorithms problems is called the hash map, unordered map, hash table, however you want to call it. What a hash map is it's a set of keys and values in a table that maps a key to a value. Why is this going to be useful? How would we even know to use a hash map in this problem? So the cool thing about a hash map is that it's very quick. You can, essentially what we're going to be using it for is remembering things. So what we want to remember that 2 is in the array, 11 is in the array, 15 is in the array, and then somehow we're going to connect 7 and 2 by knowing that 2 is in the array. It sounds really complicated, but if we break it down, it's not going to be that hard. So we're going to use a trick called the complement. We're going to be using the complement for each iteration through for each element. We got to figure out its complement. What do I mean by the complement? So the complement is going to equal the target minus whatever indices we are currently at. So for example, 2's complement is going to be 9 minus 2, which is going to be 7. So if 7 existed in our array before, we don't, obviously it didn't because it's our first element. If it existed in the array before it, we would just return I, and then we would return the value. So the key and the value, what this table is for, is remembering. So since 7 didn't exist, we're going to put down 2, and we're going to map it to its indices, because remember, that's what we actually care about. We're going to put 0 as the indices, because like we just have to remember that. So now we're going to our I is going to be 1, and we're going to figure out what the complement of 11 is going to be, and that again is 9 minus 11, which is minus 2. And we're going to look through our hash map and see if minus 2 appeared in our hash map, and we're going to say no, absolutely not. So we're going to do the same exact thing that we did for 2, which is remember it in our hash map, and we're going to put the elements itself and the indices. Now we're going to move to 15. Let's find the complement of 15. We're going to put 9 minus 15, which is minus 2. Minus 6. And we're going to look through the keys of our hash map and see if minus 6 was there, and we see that it's not. So we did not find a solution yet. So we're just going to remember it. Again, put down the value in the indices, and now finally we're going to have 9 minus 7, because now we're here at 7, and we're going to see that the complement is 2. So because 7 is what we're at now, we are looking for 2, and look at that, we have 2 in our key value pairings, and we know that we can just return whatever indices that we're at now, which is connected to 7, and we can return whatever the value of that 2 is, because we have it mapped already from the hash map. And that is it. That is going to be our plan of attack. I'm going to be going through I'm going to be going through the hash map implementation in both C++ and Python. I'm not going to, there's tons of videos on the brute force solution in those languages online. You can totally find them. So here we go. So we're going to start off with a for loop. Oh geez. We're going to be looping through the entirety of it. I++. And I'm actually going to declare an unordered map, mapping an int to an int. I'm just going to call it a umap. Now what I'm going to do first is I'm going to check if the unordered map of, well actually first I have to figure out the complement. What is the complement? The complement is going to be target minus nums of I, like we said before. So now that we know what a complement is, we're going to check if the complement is in this unordered map. This is how we're going to check it. My bad. If the unordered map dot count complement equals 1, so if there's an instance of complement in the keys of our unordered map, we are going to do something. We're simply going to return you map the value map to complement, and we're going to return I. And then if it's not in, we're going to add it. We're going to add the key, which is the element that we're currently at, and the value, which is going to be the indices. And then if that never happens, we're just going to return -1. So let's see if this works. We have a problem, and I did not declare this as an int. That works. And that satisfies it. We are good. So now let's move on to the Python implementation. Similarly, we're just going to have a dict. So I'm just going to call this a umap again. And we're going to have a dictionary. It's going to act the same. I'm going to have another for loop for I in range length of nums. We're going to figure out what is our complement, and that again is going to be target minus the current nums. Now we're going to see if umap if complement not in umap, we are going to add it. So we're going to say umap complement equals I. Actually, no, we're going to, similarly, we're going to do nums I is equal to I, and then else. So if it is in the unordered map, or just a hash map, or dictionary, we're going to say, we're actually just going to return the list, which is nums I, which is actually, my bad, the umap of complement and I. Very similar. We're going to return a list of -1. Let's cross our fingers, hope that's fine, and it is. So those are the two implementations of the hash map approach in Python and C++. If you guys like this, like, comment, and subscribe. See you guys in the next one. Thank you guys so much. Bye.